Okay, so we are starting the recording, and let me go to my lecture here. My lecture is shared. The recording started. My handset here is connected. Okay, all this technical stuff I hope sorted out. So let's go here to my lecture. Okay. So the mouse does it change here? Okay, okay, good. All right, so um, I think where we stopped last time was we looked at the okay, so we discussed the normalization step, data processing, and all that nice stuff. Okay, and we're going to talk about the weight initialization, and the weight initialization. There are lots of talk about how we start the weight initialization of a machine. I'm gonna focus on this slide here. Um, in general, for our assignment, since the machine is small, I would say start your weights random values that are small. Okay, that are very small. Um, okay, so I'll get back to you. Okay, that are very small, and then there are the recommendation for really large neural networks. But for our assignment, start small values, and yani small means what? Around one, less than one, negative and positive. Okay, and sprinkle them around. The student asked me last lecture, should I create a random function? Should I assign them? Honestly, because we have the design is small, you can do either. Yeah, I don't have a billion parameter for me. When I start having millions and hundred of millions and a billion parameter, yeah, we need a very nice random function that does this distribution of a bell curve. Okay, but our weights are barely, so you can do it by hand. That's the point. You can initialize them by hand. Now for small, initialize these with zero mean and 0.01 standard deviation. It means 0.01 standard deviation means don't use minus 100, right? Don't use 1000. Make them less than 1 in general. Make them less than 1. Don't use zeros. If you use weights of zeros, so you want to start this machine in a very nice زي الدو زي العجينة يعني you can shape it the way you want. The large weights somehow العجينة عويصة بتصير معك. Okay, it probably eventually it will get to where you want, but after a very long time. Okay, now for deep neural network, you can initialize the weight to random numbers, normalized distribution with zero mean and standard deviation 1 over square root of fan in. How many inputs are getting to the node? Let's say each node receives, let's say, 1,000 weights. Okay, so this becomes your standard deviation. But of course, we are not doing that. Okay, so this is ReLUs are used to when ReLUs are used as activation functions, it's better to initialize them to random numbers, normalized distribution with zero mean and standard deviation 1 over square root of fan-in over 2. Okay, because the ReLUs have this nature of wiping out half of the spectrum, because half of this, if your input is negative, it will make them zero. So there's a better standard deviation for them. Biases, always to zeros. We know what these biases. When you multiply the inputs with the weights, and at the end you add a bias, okay, before the activation function. So all these biases always start with zeros, okay, and then let the machine learn their optimum value. all of these recommendations هسه ممكن واحد يجي يقول والله أنا started my weights by tens and hundreds وزبطت معي. Fine. Remember, these are guidelines, and these what we are talking about for deep neural network. And for smaller neural network, we said that the number is a lot small in terms of the standard deviation. These are guidelines and collective experience, let's say, steps of people have learned how to get these machines trained in a successful way. Okay, we talked about the batch normalization. I'm not going to repeat what we talked about it. It's between the steps. Hyperparameters, okay. There are multiple hyperparameters that you can train, and in fact, one of them, if you okay, let me leave this for a second. Okay, the learning rate. I want to talk about the learning rate. If you the learning rate, which relates really to our project, there was a very common question: what would be the right number for learning rate? People, the 0.05, 0.01 seems to be, around what people try to use as in terms of learning rate. You can have those decayable, those learning rates, and they change in your training. Okay, I don't think we need to do that for our small neural network. But here is a graph that shows this is the loss of the network. How look at the red line here, how a good learning rate, right, decayed very nicely, because what you want is that you want the loss function to reduce as you continue your learning. Okay, a lower learning rate, يعني مثلا 0.00001 مثلا for example, you will see that the network is learning very slow. That's the blue line here. Well, okay, so what happens if you have very high learning rate? Because I want to learn quicker. Okay, what happens is that you're going to end up in regions of the optimization unexpected. I have seen this, by the way. شايفين هذا اللي طالع فوق؟ I have seen it. I have very high learning rate, say 0.5, or was 0.5, it's something like 0.5 or 0.1. And all of a sudden, the loss function is exploding. And I'm like, what is going on? That's in early examples that I was doing for neural network. The neural network should have learned, right? It should. In fact, I think it's in one of the examples. In one of the examples that I show in the learning in the neural network training, there was this one example that the weights just exploded and the loss function went through the roof. And this is because you have used very high learning rate. Okay, all right. Remember, all the math that we promised you, all these derivatives, right, they all succeed if you are in a reasonable region of learning rate. Okay, very high will set you in a bizarre region. Very low, you will be very slow to. You have to learn through experiments, right? In other words, I cannot look at a neural network and I say the best learning rate is 0.005. That's really hard. That's somebody probably. Well, what about 0.006, for example? Okay, so nobody knows the best learning rate for your machine. Even you, when you start, you don't know. You have to do 3 to 4, 5, 6, 10 experiments, and then you say, oh, okay. That 0.5 is not good. That 0.0001 is too slow. let's be around 0.001, right? 1 in 1,000 or 1 in 100 or so. Okay, 1 in 1,000 actually slow. Okay, and I have seen it. I have seen some of the machines that I worked on my research that changing the learning rate got me to where I want. And I've seen this curve that goes up and explodes in loss function. I've seen it. Okay, so learning rate in the hyperparameters, I think it's one of the most sensitive and dangerous, right, parameters, but حط لي خط هان for large neural networks. Okay, for small neural networks, 0.001, 0.05 seems to be A-OK. For the assignment, I'm expecting the values to be around that neighborhood. If you succeeded with 0.1 learning rate, good. With 0.1 learning rate, that's beautiful. If you did not, then you might want to you might want to you know, experiment with you know, different values. Okay, yeah. What was the question? Loss here يعني يرتفع هان. Okay, so the question is, in the red line here, is it possible right at the end where this will shoot up? Highly unlikely. Highly unlikely. What I would expect it, Muhammad, is to go flat. And in fact, then the question comes in, why it's not going flatter, why it's not going lower. It has to do now with your architecture. It's a different problem than the learning rate. Maybe you need to look at the activation function, the number of neurons in a layer. Maybe you need to. So in other words, if you get this, if you get this red line, you won the learning rate lottery. You are good in terms as far as the learning rate goes, right? Now, why it is flat and it doesn't go lower? That's because something else. If it shoots up, that's because something else, not really the learning rate. Okay. Okay. Some people, what they do, they do this decaying of learning rate. Now, again, I'm talking here about really large neural network. You change the learning rate. Okay, you start with some value of learning rate and you decay it, right? And every time you decay it, and the idea is you really need to learn less as you train the neural network. You can experiment that yourself. Yani, lock in your database into some learning rate. Yani, save the parameters. Then go change the learning rate. If you get better performance, then save those new parameters. If you don't, go back to your older parameter. Yani, I'm afraid changing learning rates without experience might get you this going up here. Okay, so people claim, you know, if you use a learning rate, one value, then decay it, يعني قلل you can do this. I am not very confident of that unless you really know what you're doing in these complicated. And remember, sometimes these experiences come out of teams which has tens and hundreds of engineers. So you alone. Wrestling with this neural network, I will always play it safe and standard. Although it is a lot of people reported that decaying the learning rate helps. Okay, but in an assignment setting, don't do it. It's just people reported this for large neural network. Okay. Okay, so not recommended for optimization techniques. Okay. Okay, loss and overfitting. Yeah, overfitting, I get asked about overfitting a lot. And it is the question of, define for me what is an overfitting. Okay, an overfitting, I'm going to give an example where it probably relates to what we are doing, which is learning. Okay, and I suppose, for example, we want to train somebody on how to use a car. right? So what we do, or how to drive a car, sorry. So what we do, we have this street right in front of our college building, and we take this individual and we train this person on this street alone. Okay, رايحين جايين واحنا we are teaching this person where so we train this person now knows this road very well. In fact, this person now memorizes this road very well, which is not good, because the objective is to learn how to drive. And what we ended up with, because we use limited set of training, this person now memorizes the road. In fact, you can fold this guy, you can blindfold him, and he will drive up and down this road with no problem. Now we take this person to other, okay, we take this person, see, so this is now this guy now driving the car beautifully on this single street. Now we take the same person to a testing area, and whoops, the same person driving skills are bad. Can't take curves, cannot drive upslope or downslopes, doesn't know what to do with rotaries, right? So what's the problem? The problem, we trained this individual on a limited set of streets. So when you train your machine on a limited set of images, of text, of whatever you are training, there comes a point your machine will learn, very quickly will learn, and then start memorizing. And that's bad. Okay, so now technically let's define the overfitting, which is the memorizing of data, not learning from it. Overfitting says you are doing extremely well on the training data, and then when we test your machine, it does very bad. That's overfitting. Your machine memorizes its data, the training data, but it cannot do anything good when it's tested in a data that it hasn't seen. Okay, so the causes of the problems many. On top of them, your data set is limited, and you are crunching these training more and more, because now you are fine-tuning your machine to memorize the data, to memorize the street. Okay, once it goes outside the scope of that street, of that data, that overfitting becomes a problematic, not an advantage. Okay, now, so what's the solution? Well, the solution always is that when you train when you have your training data, people do have some kind of like a rhythm for the training. So you train your data. When do you stop your training? You have a small set of your training data set aside called validating data. So you check those validation data if you reach to a certain level of your objective. Then you take your machine and test it on data that has not been trained on. Now, if you get a large discrepancy, yani, you are doing in the validation data, right? A lot. Well, that's seems to be sorry. You are doing very well in the validation data. Okay, I'm not going to touch this area. You are doing very well in your training data. You are doing very well in your validation data, but you are doing bad in the test data. Here's what I want to tell you. You're probably cheating yourself on the validation data. ليش? Now, a lot of times what people do is that this validation data is some of the trained data. كيف؟ لأنه every time you go through a training, you set aside few images for validation, and you use most of the images for training. Right? You train, you check الفاليديشن، طلع لي 90% accuracy، ممتاز، انا مبسوط. روح على التست data which was not used، right? 50%. طب what happened? Why your validation data, which stopped you from continuing the training? So you have a problem here, okay? So it's all starts with data, right? If you have limited set of data, if you did not partition your data properly, okay? If you have not set aside validating data appropriately, okay? So the data has to be clustered into testing, not to be touched, and training. Training, most of it, use it for training and leave few for validation of your training, okay? The testing, you should be honest with yourself, should not be part of the training. يعني ما بصير أنا عندي software to detect images of, I don't know, male person images. أنا عندي testing 100%. تاخذها agency من عندنا في البلد، تروح تسوي testing قبل الديبلويمنت بيطلع عندهم 50%. Why? There's a problem. There's a problem with. طب هلا أنا سويت testing. لا تعال وريني كيف سويت التستنج. إما you didn't have enough tests or you trained your machine على testing data. يعني في عندك شيء غلط. لأن اشمعنى هذول جابوا 50% accuracy وعندك حضرتك جايب 90%. There is a problem. وبالتالي أنا بقول للناس دائما يعني it's recommended. Be honest with yourself when you test your machine. عادة 70% give and take around training, 30% testing. عندك 1000 images, 700 of them goes to the training, 650 probably for training of the machine, and 50 for the validation. That makes up the 700. And then 300 for testing. لأنه testing, you will sell this product. Shame on you to report 100% accuracy, and then people find out it's 50% or less. Okay, that's roughly the story of data. And the overfitting is a result of somebody did not start with the right set of data. And عندي images, I want to recognize images of numbers. بروحش اجيب 1000 ولا بجيب 2000، اشتغل على الملايين. If you want to do real tough work, professional, تحت المليون تجيب السيرة. تحت ال 1 million images, don't even bother mentioning a data. First of all, data sets are free or can be bought at cheap price. Second of all, now machines that are sophisticated and high with accuracy, they are trained with billions of data. Okay, so the overfitting happens when you have really limited set of data that's your machine now memorizes the data and not learn the data. Okay. So does epochs overfitting the main symptom? It might, okay, but the main reason for overfitting is the currently driving session. Okay, data is limited, right? When your data is limited, لأنه learning جاي لي أنا من الداتا تبعتي. If the data is limited, then what I will learn is limited. If the data is rich, then I can learn a lot. Right? Okay. So I would blame overfitting. Okay, there could be these are secondary reasons at the bottom. بس إذا بتيجي بتسألني والله أنا عندي في الأسايمنت overfitting problem، بقول لك data. دير بالك. انت عندك you have a good large machine, right? Intelligent machine زي السواق اللي رايح جاي، بس ستريت واحد حيحفظه. I was well, since this is recorded, I'm not going to say what I want to say. I want to say some joke here, but okay, problems in stochastic with this, so we reached to this local minimum. I'm going to stop here because I want to go to the assignment. Okay, so let me go to my recording now and stop my recording. Okay, stop my recording. This is going to go to the lecture depository.